Hello, AMC students. I just wanted to show a couple of these logarithm problems here. And so I will go ahead and do problem 1, and then I'll skip down and do one of the log equations, and I'll even show you the challenge problem. But don't watch it if you want to try it out yourself. So problem 1, we've got 2 to the 4x minus 2 equals 64. We're going to go ahead and use a log base 2 on both sides because that will eliminate the base of 2, the exponent. So now we have 4x minus 2 equals log base 2 of 64. You can either get that by counting up powers of 2 until you get to 64, or you can use our good old friend, the change of base formula, log 64 divided by log of 2, and typing that into your calculator. If you do count by powers of 2, you go 2, 4, 8, 16, 32, 64. So we have 4x minus 2 equals 6, because that was the power of 2 that made 64. And then you're just solving it like you've been doing for years. Add 2, 4x is equal to 8, divide by 4, x is equal to 2, and there you go. So we use a logarithm to cancel out an exponential function. All right, moving along to one of the logarithmic equations. I just want you to notice it's really important to pay attention to when things are inside the parentheses or outside of the parentheses, and that just impacts the order that you solve in. When you are plugging numbers in, you use PEMDAS, so parentheses are first. But when you're solving, you're undoing, and you can think of it as SADMAP, where you have parentheses as your last step. So I'll go ahead and do problem 4 here. Notice the parentheses, the 3x plus 1, that's going to be the very last thing that I do. First, I want to get rid of the logarithm. Logs and exponents are inverses, so I repeat the same base, and it cancels out the logarithm. So I have 3x plus 1 equals 4 raised to the third power. Count up on your fingers. 4 times 4 is 16. 16 times 4, 64. So 3x plus 1 is 64. Then we're just solving like we know how to do. Solving 3x equals 63, divide by 3, x is equal to 21, and you got it. So you're still using all the same solving skills, we just have these new pieces of logarithms and exponents. All right, now I really encourage you to try the challenge problem out yourself before you watch this part of the video. So here we have a logarithm, and I can't just go at it and do a base of 3 because I've got logarithms in 2 different spots. I would have an addition problem up in the exponent. I guess you can do it that way, but I think the nicer way to do this is to use your log property. And what was our log property? If we have log of x plus log of y, that's the log of x multiplied by y. So we're going to utilize that here to make this into log base 3 of x plus 3 times x minus 5. And that's going to equal 2. Next, we're going to raise both sides. We're going to use the base of 3. So we have x plus 3 times x minus 5. 3 squared is 9. Now, at this point, you might be tempted to try to say, oh, it's negative 3 and positive 5, but that only works if it's equal to 0. So I actually need to do a little bit more work here. What I'm going to do is multiply everything out, 0 it out, factor it, and then we'll move on from there. If I FOIL this out, I got x squared minus 2x minus 15 is equal to 9. I combined the 3x and the negative 5x. And so if I want to zero that out, I have x squared minus 2x minus 24 is equal to 0. Just going to slide that up there just to finish this out. Factoring, x minus 6, x plus 4 equals 0. Tells me my two potential solutions are x equals 6 and x is equal to negative 4. But being a good little math student, I'm going to remember that you can check your solutions. And if you plug them back in, they should work out. So if I plug in x equals 6, I have log base 3 of 6 plus 3 plus log base 3 of 6 minus 5. And that's totally fine because this is log base 3 of 9 plus log base 3 of 1. That equals 2. So I feel pretty good about the x equals 6 solution. I'm just going to erase that stuff. Because when I plugged it in to the original equation, everything was fine and dandy. When I plug in x equals -4, same sort of thing, just double checking, does that work? Log base 3, -4 plus 3, plus log base 3, -4 minus 5, and that is a big problem. We can't take the logarithm of a negative number because exponents never reach negatives. They have that asymptote. So we have to say that x equals -4 is an extraneous solution. The only solution is x equals 6, and we are done. Reach out if you have any other questions about anything in this assignment. Thank you.